So it's good to have you here, Benoît. I think this is a new experience for us, and we're very happy that John Cockerill was visiting, and we thought, why not take this opportunity for an informal conversation?
And my pleasure.
Yeah,
My
thank you.
pleasure to be here, Professor.
Perfect. And so maybe we'll start with, could you just give us for the viewers a brief background about you, what you studied, and what you do now at John Cockerill?
Okay, no, quickly. I'm a physicist by education with a PhD in physics, in polymer physics, and worked during 20 years for industry, in chemicals, in oil and gas services, did a little bit of strategy consulting, and went back to industry now to clean energy, both by conviction and because there is a good appetite for, in these new domains, and joined green hydrogen 4 years ago through a French company, McPhy Energy, that has been absorbed by John Cockerill Group, and hence have been working for this Belgian company for 1 year now.
Okay.
But still in green hydrogen.
Now that's great, and maybe a bit of an introduction also to John Cockerill as a group. I mean, what they do, and how long has been the history with green hydrogen that could help too.
Yeah, sure. John Cockerill's story in green hydrogen dates back from 2018. They entered this market as many others, and through a technology that they purchased in China, but now they have both an industrial setup in Europe and in China, and also coming soon in India through one of the biggest projects in the world, 640 megawatts plant, green hydrogen plant that will serve green ammonia plant on the eastern coast of India. So John Cockerill is quite recent, as many others in green hydrogen, but has now more than 7 years of experience. And for the rest, it's a group of 1.6 billion euros revenue, operating in steel industry. That's the DNA, the root of this group. But this activity has also been developed in a defense segment. So they were building some turrets made of steel for the defense industry, and also in some energy business. And all that started by a service activity that is helping all the others to get developed.
Excellent. So you mentioned this large plant in India, the 640 megawatts. I mean, looking at the numbers, that's an impressive scale of plant. Do you want to say a bit more about this plant, and what are the timelines? Anything you would want to mention about this Indian operation that you are setting up?
Yes, it's indeed the second largest project in the world.
Oh, wow.
After NEOM, the well-known NEOM project in Saudi Arabia, that is currently being commissioned, if my information are correct. As for the project of John Cockerill with AM Green in India, the final investment decision has been taken now, I think 2 years ago. So it's really a project that is being implemented. And that will be commissioned, to the best of my knowledge, somewhere in 2027, somewhere next year, towards the end of the year. But it's really in progress, and that is the flagship project of John Cockerill, because that's a proof of our technology at a very large scale.
I mean, second largest in the world is quite impressive for all of us, and for India, quite a proud moment.
Now there are other projects in China, and I've one in Sweden in my mind, that are approximately the same size. But it's really I mean,
yeah, one of the large top projects. Now, they're very, very interesting. And now, for a project like this, you're going to manufacture the stacks in India, or what is the in green hydrogen? Where do you see India as a part of John Cockerill's global strategy? Is it for manufacturing? You see a lot of other scale projects come up. Where do you see the next 5 to 10 years going?
Clearly, India has a very important role to play in green hydrogen. And for us, John Cockerill Group, that's definitely a country where we want to get developed through a team, engineering team, sales team, manufacturing team. We will have this plant in this area where we will have this project. But overall, India is one of the countries in the world that is taking the green hydrogen revolution seriously. So there is a big development potential. And by the way, we were chatting together, but today there are something like 5 million tons of hydrogen consumed per year in India. That makes 5% of the world consumption. 5% is an important number. So just converting that from gray to green would, save a lot of greenhouse gases emissions. So, and Indian government is really showing a will to do that. Very aggressive and ambitious plans. To be able to manufacture 6 million tons of green hydrogen by 2030. Very ambitious. I don't know what will be the situation in 2030, but the bar is set very high. And so for us, it's as one of the key OEM in the world, it's definitely a country where we want to be. And so this flagship project in Kakinada, on the eastern coast for this refinery and to be able to manufacture green ammonia is an extremely important project that we want to succeed.
No, that is great. And so in the Indian context, obviously you're setting up these plants where the hydrogen is going to be produced. You also have stack production. But since we are at IIT and Research Park, what are the directions in R&D in the whole, when you build a stack or a company like John Cockerill develops its new electrolyzers, how is the research like, and do you see opportunities for engagement with, say, the IIT Bombay ecosystem? Where do you see India in the whole research plans for the company?
Definitely, yes, we see some potential collaborations with IIT Bombay. There are still things to improve in this technology. People tend to think that it's a mature technology. It's not really true. There are still things to improve for the electrode, to improve for the diaphragm or the membrane, and also to find all the ways to decrease the cost down. What will really drive the consumption of green hydrogen up will be matching the price of gray hydrogen. Today, we are still not there, but not very far when you look at very large green ammonia projects using either green or blue hydrogen, just for the sake of the clarity. Green hydrogen is hydrogen produced through water electrolysis and using some green electricity. Blue hydrogen is production of hydrogen with fossil resources, fossil fuels, but where you capture the CO2 and you reinject it inside the geological layers, so you just avoid to send it to the atmosphere.
Of course.
So green and blue are decarbonized hydrogen, and we see that for the large green ammonia projects, prices tend to come closer between gray, still more attractive price-wise, and green and blue, but getting closer. So there is need for technology improvements, hence R&D with patents and IP being developed for everything that will drive the cost down. I think we are here in a revolution like solar panels, like wind farms, where price will continuously being going down, and everything is contributing to it. Some more fundamental research, like catalysts, on the electrodes, or some very simple tricks that makes your electrolyzer more robust and able to sustain, a longer industrial life. You need to fix all these issues. Today, these products are industrial products, but that definitely needs to be used at larger scale. We need to show, to demonstrate their use at larger scale.
So there's two issues. One is the unknown unknowns. Research, you discover a new trick or a new catalyst, that's one. And the other one is the economies of scale, right? As you start bringing large plants, you get... But sometimes a critique I hear is that when you see a green hydrogen plant, of course, there's the stack and a lot of research is possible on the stack. But then you have the more conventional components, right? A lot of piping, heat exchangers, compressors. If you look at the experience curve of solar, for example, as time went past and we built more capacity, the price really came down, maybe, but really rapidly. But in other areas, say gas turbines, etc., right, price plateaus out. What are your thoughts? Like, as we build larger and larger plants, how is the levelized cost of hydrogen going to come down? Is it going to come down rather rapidly? Because sometimes critics say that, look, only certain parts. What do you think of that?
For the stack, I'm sure it will go down like solar panels.
Okay.
For the rest, the balance of stack, that is less straightforward because it's more conventional.
Yes, piping, mechanical components.
Mechanical components. That may plateau out. May.
Okay.
But again, economies of scale will play a role.
Okay. So when you build larger factories, the prices are coming down. So that leads to the second question. You mentioned the LCOH, and if you see European projects and if I read reports, right, whichever you trust, what is the typical price per kilo that you see? And the Indian, the recent tenders have been quite optimistic and everyone's happy they've discovered a price which is very low. Where are the regional cost differences, like Europe, India, China? You see all of the globe. Where do you see project pricing vary? Where are there certain advantages? Is it the amount of solar that you get, the cost of execution, the renewables? What are the top 2-3 factors which distinguish pricing?
Top one, the clear number one is electricity price.
Okay.
And it really varies depending on your region of the world and also of the type of the project. Is it a project linked to, a continuous process where you need to produce continuously hydrogen? Therefore, it's difficult to be purely using renewable energy. So you need also to be connected to the grid, which is usually more expensive. Or non-continuous processes where you can afford to be purely linked to renewable energy. So your electricity price is coming down. However, you are spending the same capex, the same plants for only half the time because you just use, solar panels that are producing less than half the time of being continuously linked to the grid. You have also mixed schemes. So all that makes it quite difficult to answer your question, but electricity price is number one. It varies, clearly varies in the regions of the world, but what is more important is what is the need in your project, and how do you mix renewable energy with other type of either storage or grid feed. Well, second part of the cost is indeed building the hydrogen production capacity. That has to do with the stack, with the balance of stack, the balance of plant, or civil works. In Europe and US, it's more expensive. In Asia, obviously less expensive. And it definitely makes a difference. And that's also to answer your question, what is the role of India? India is typically a country where we can build this balance of stack at lower cost than in Europe. That's obvious, but seems obvious maybe to us. But I mean, at some point we thought we could do it in Europe, and now no. Economic reality is just, I mean, coming back to us.
So when you do these projects, Benoît, how does, for the benefit of the audience, like John Cockerill as a company, would you just sell the stack, or would you also do I know you have a collaboration, I think, or had with Technique, or I mean, would you do the whole engineering? What is the structure of a typical project? At what point does John Cockerill come in?
And there's not one size fits all answer, because depending on the project, we can either sell stack and balance of stack, or go a bit beyond, but usually we partner with an EPC company and we supply what is really our core scope, which stack, and collaborating on building the right balance of stack.
Got it.
But for the rest, it's not our core knowledge.
Got it. No,
in some cases, we can do it.
Okay. So coming to the stack, right? I mean, a lot of the questions people ask are about membrane life. These projects have a long period, and any comments about how what kind of research you guys have done? How do people predict membrane degradation and things of that nature?
It's still a field of research, and that can be good for your students because. Alkaline technology is quite well known, but what is not known is the degradation behavior, the long, I mean, the aging of all these chemical components. There are physical phenomena, chemical phenomena that are degrading the initial performance of your stack, therefore the engine of your hydrogen production. So the electrochemical reactions, physical and chemical phenomena are degrading this efficiency, and this part is not that well known. So there's still plenty of room for improvements, academic research, patents. And so membrane degradation, we know a little bit, but...
So an active area for research and young guys to work in. So that being said, now we can't really wait. I mean, the world needs green hydrogen, or we need to decarbonize. So with the reality of such a complex phenomena, How do you see owner-operators de-risk, or do you have any tips or tricks? How do people, because when they plan a project and they need to figure out when to replace stacks and things like that, what approaches, what's a practical way for people to design these projects?
And it's quite easy, is to be able to take the stack out of the plant, so by replacing it by a new stack, and the old stack, you just reopen it. So your technology must be compatible with the refurbishment. And then you reopen it and you replace components that are degraded.
Yeah, so it's not the end of, I mean, you can always retrofit depending if you have some variability in how degradation is going to happen, right? Because that's otherwise one scary thing for a lot of people, but you can deal with the unknowns. Yeah.
Providing that your technology is compatible with such a refurbishment.
Perfect. So that's one point. And now you mentioned Alkaline, right? There's Alkaline, and I see a lot of projects right now getting built with Alkaline or pressurized Alkaline. But there's always the PEM. Like, as a company, how do you view PEM? I mean, is it coming closer to price parity? Does it make sense for certain niche applications in terms of the ramp up, ramp down? Where do you see PEM fit in the whole picture?
I tend to think that there is a market for all technologies. Alkaline, the acid technology, which is proton exchange membrane or PEM, or even the SOEC technology that is using a very high temperature water vapor. I think there is room for all these technologies. The dominant technology today, in figures are very clear, is Alkaline, but PEM technology, I would say, is approximately at the same level of maturity as Alkaline. SOEC is still mostly in a pilot stage phase, but PEM and Alkaline are equally mature. We have good competitors in PEM technology.
But then how does it explain the share of projects right now tends to be more towards Alkaline, right? Is PEM still not cost competitive, or how do you look at it?
The only difference, and I was about to come to that point, is that for PEM, they still need some precious metal as catalyst.
So it's the iridium dependency.
That's the famous iridium dependency
Okay.
That people in this field are very well aware of. But because this iridium is scarce, its price is very high. Obviously, they are using very small quantities, but still, these small quantities makes this technology I would say a bit less cost effective than Alkaline. Therefore, for large project developers tend to favor, but not only, tend to favor Alkaline. But PEM is working also at decreasing the iridium content, and maybe one day will succeed to get rid of it. It's a big area of research. Honestly, there are a lot of academic papers on new catalysts for PEM.
So guys like you you keep watching and
Today, just to give you a simple figure, today in terms of projects, of volumes in terms of megawatts or quantities of hydrogen produced in the world per year, of new projects per year, it's typically 70% Alkaline, 30% PEM. But when you look at the number of papers in academic research, it's 70% PEM and 30% Alkaline, or even less Alkaline. So, a lot of research in PEM, probably obviously to improve cost effectiveness, but there are good products on the market, and today they are indeed a bit less in large projects and more in smaller projects where smaller footprints makes more sense, and therefore PEM is privileged towards Alkaline. But again, I think there's room for everybody.
Everyone. Okay. Now, shifting gears a little, I mean, once you make the green hydrogen, of course, there's green ammonia, and looking at one of the end users, I mean, shipping, right? Like, that's a hard to abate because you can't really put batteries for large marine shipping. But there's always this talk of green ammonia or e-methanol, and maybe both of them, of course, can use hydrogen. Where do you see the field going? Like, is the jury still out? Where do you, like, what are your predictions on the marine shipping sector as a whole?
Oh, personally, I think jury's still out.
Okay.
And there are some discussions worldwide that are, I mean, for the long-term regulation of this sea transportation, maritime transportation field. No, jury's still out. I'm quite confident that I mean, things will evolve towards more renewable product, I would say rather soon, but we will see the effects only 10 years later. So what will really show, I mean, what will be the trigger of green hydrogen growth, for me, will be more green ammonia. Or the sustainable aviation fuels driven by this European regulation. I mean, still, we don't see many projects, but many are being
Conceptualized, yeah?
Conceptualized.
Got it. Got it.
So, for me, green ammonia will be first with sustainable aviation fuel, green methanol, and later on we will see new fields of development.
But if you look at Europe, for example, we were discussing this earlier, this whole hype wave, and then the projects that come to FID were lesser. But there is now that the offtake agreements, etc., are in place, I think we are doing better. So what is the learning experience for other countries, say for India? Like if you follow RFNBO policy and the way Europe did it, of course, some things went right. Any thoughts on...
You are quoting RNFNBO. It's complex regulation. Obviously, the first lesson for India is to avoid such complex regulations, make it simple. There are discussions in Europe to review that. But now taking your question as a whole, and over the last years in Europe and the subsidies that were planned and that are not all there yet, what happened and what can be a good lesson for India. I think one of the lessons is to really have a long-term effort. And that's what I regret in Europe, is that, okay, green hydrogen has been a hype, but we were expecting from governments and from European Union to continue the effort. They are doing it, and I don't want to throw them a stone, but we see that after this hype, there has been, some people were not as interested that they were in green hydrogen. Hence, the effort has been decreased, but still there. But really to keep the same pace during a long period, that only allows big things to happen.
So long-term policy certainty. Huh?
Yes.
Once you stick to the course and then let
a sustained effort. Otherwise, this kind of revolutions will be more difficult to achieve. Interestingly, the decarbonisation effort has now turned into a sovereignty effort. So some people are now seeing that green hydrogen is a way to produce sustainable aviation fuels in areas that are not bound to geopolitical issues, or that this fuel or that green hydrogen can be an energy vector that you can generate in your ground. So some countries are seeing green hydrogen both as a way to fight global warming, but also a way to gain more sovereignty on industry development and energy sources than just using hydrocarbons.
Yeah. So when a war happens,
sovereignty is,
another dimension, the geopolitical
another
advantage.
dimension of these developments.
Yeah. What do you think of other sectors? So, for example, a lot of the discussion is centered around green ammonia, but like chemicals, for example, right, uses a lot of hydrogen. So, do you think policy or the whole public discussion has had some blind spots in terms of, do you think it would be interesting to convert some of the chemical users where there's no alternatives, right? You have to use hydrogen, like unlike, say, transportation where batteries are there or heat pumps. There are certain sectors where hydrogen is the only choice, and right now they are using grey, but you could switch them to green. Do you think these smaller sectors, they may not be as large as ammonia, but maybe they support a 5, 10, 20 megawatt plant? Do you think that's an interesting market segment?
Yes, but the price of green hydrogen will be higher because the project will be of smaller size. There's obviously the size factor. So that's why now project developers are going to large green ammonia projects that are really driving up the market. But yes, it makes sense. It makes sense, and there will be probably a need for more governmental support to pay the difference, because indeed with these smaller size projects, price will be higher, so the difference between grey and green will be higher.
But yes,
projects, it makes sense.
They anyways pay a higher price for grey at the moment than some of the larger guys, right? Where I'm going to is sometimes green hydrogen is critiqued, rightly or wrongly, in the sense that for certain areas, there's competition, heat pumps, batteries, and projects. So there's that uncertainty, but there are certain bedrocks of the economy where hydrogen is going to be used in any case, right? Like if you need it for a hydrogenation reaction or a hydrodesulfurization, there is no competing technologies. You can either go grey hydrogen or green hydrogen. Yeah, but I don't see, so that was sort of where the question was.
Yes, and that's where people need to gain confidence in the technology. And so all this industry needs to generate, to have these projects running, generating data, so that it can be a positive circle.
Correct.
With this data, some companies can say, okay, now I see that it works. With this experience, I can take the risk. But today, we are a little bit trapped in between these projects that are, there are not so many large projects that are generating data.
So that's where I'm coming to. When you see a lot of other technologies, the next larger project that the world builds is say 50% larger or something. But here's a field where at this intermediate scale, right? So if you are aiming for the 500 megawatt projects, you don't really have, in India, for example, a lot of projects in the 100 megawatt or 50 megawatt range. What has led to this peculiar development that we have everyone interested in the super large projects which are going to take 3 years, but in the intervening period, you don't see the smaller, is it the nature of policy, government? What's that bias?
Several answers to your question.
Yes, please.
First, indeed, in India, we don't see that many small projects, but you see them in Europe. So you can find them in Europe. There are, I know, many projects between a few megawatts to a few tens of megawatts.
Okay.
So, and these projects are currently being built, and some of them have already started and they will generate data. Well, they exist, but maybe not here in India. But this world of green hydrogen, I mean, you need to take, I mean, it's a chemical, you need to take risk, and that's a field where oil and gas companies are comfortable. That's their world. And I remember talking to some executives of a large oil and gas group in Europe, and they were saying to me, no, we don't want a 20 megawatt project. Our CEO forbid us to make one.
So it's too small.
Yeah, too small. We need to go to 100 directly.
Okay.
So I think it's what you are saying. These project developers, just by nature, they go directly to large scale projects. Okay. For good or for bad, because they are missing the experience curve on smaller projects. Maybe for good, because they go directly to what matters. But your question is right. We are missing.
So the financiers don't see it that way, right? I mean, if you want to take a risk, they would want to see a lot of small stuff before they see a big risk. Yeah? So switching gears though, I mean, what about China? I think when you see the lists of the IEA on the green hydrogen projects, a lot of large ones are in China. Any comments on what China has done or how their policies, sometimes that ends up being an opaque part of the world for a lot of, but you guys have built projects in China.
Also, yes, we do.
How's China? I mean, Europe's very transparent. We read a lot. How has China handled hydrogen policy?
I'm quite impressed personally by the Chinese government really driving this change. It appears, green hydrogen appears among the 7 top priorities for their 5-year plan for 2030. I mean, just next to human and machine interface. I mean, in the brain. I mean, futuristic project.
So they put it high up on the list.
They put it very high on the priority list. Okay. So that's a proof that, like in India, they are taking this change very seriously. And today, more than half of projects, I mean, green hydrogen projects in the world, more than half are in China. Great. So they are really putting a lot of efforts. Now they have difficulties because by doing that, they have created many companies just copying each other to make electrolyzers. It's driving prices down. To probably an unsustainable price.
So there'll be some
it's kind of a bloodbath.
Clearing which is going to happen.
Market consolidation will obviously happen. I don't live in China, so I cannot really comment much more. But we have seen a press release saying that all these companies met together to say that they don't want to drive prices down more.
It's a whole different style of functioning.
For us in Europe, it's just forbidden to gather to decide something like that.
Fix a price like that.
But okay, they did it. They had a press release on that because the situation is quite serious. But now, let me use this word serious the other way around. They are very serious in developing it, and they will succeed. And they are succeeding. They will have very good companies with, electrolyzers at low prices, and it may happen that, like for solar panels, that most of the green hydrogen electrolyzers will be Chinese in 20 years. It may.
So they've taken a bet on the area.
But at least they are taking the right steps to do that. They are taking it very seriously. So that's the way I see China as a a serious competitor and a real threat.
No, thanks for that comment. Now green hydrogen, of course, for renewable, for CO2 mitigation, yes, everyone's looking at replacement. But do you see a role for green hydrogen also in the context of grid stabilization? So what I mean is when there is curtailment or when you need to balance this as the percent of renewables goes up, is it practical, or the capex of keeping plants idle, or do you see any tricks to make that work? How could it stabilize the grid or provide something?
Yes, it could, but not now. We really need to have cheaper electrolyzers so that it makes sense. But what we see in Europe is that more and more we have negative electricity prices. When you have electricity at zero cost, you can, providing that you can do that quite often and that the price of your capex of your electrolyzer is not too high, you can manufacture for free, or beyond the capex cost, some hydrogen when electricity price is zero or negative.
So it just depends on how cheap you can make the electrolyzer
yes,
to take
today it's not cheap enough. And today there are not so many periods where electricity price is really low
enough.
But it will come, because the more renewable energy will get developed, the more, at least in some countries, and
there'll
speak
be
for
pockets
Europe,
where it makes sense.
There will be some places where it makes sense.
But in terms of storage right now, because you see a lot of projects and feasibility studies, where is the world going? Battery storage, there's pumped storage, but the sizes are limited. Or can you actually store the hydrogen? How do projects look at that? Like adding storage because for the nighttime hours or when there isn't solar, what are typical strategies that people are adopting?
Again, I think there's room for all sorts of solutions. It's difficult to
maybe pros and cons. Like where do you see battery storage going versus pumped versus actually storing hydrogen before the ammonia stage? What are some general heuristics?
No,
it
pump
just depends.
Pump storage is clearly the most cost efficient, but you cannot develop
it
everywhere.
Yeah.
Then battery storage will be really linked to the cost of batteries. So therefore, the cost improvements in batteries, and also to degradation of batteries, because that has to resist over time. And for hydrogen, I give you my answer. Today, I don't think it's really making an economical sense
to store,
but it may come depending on the cost evolution of electrolyzers.
The question from the IIT, the student point of view, right? Talent is always under discussion, and sometimes in Europe with aging and all that. So do you see this as a good area for younger students to take a bet on, like the hydrogen industry, in terms of jobs, wherever they are, R&D, maybe strategy, maybe production? What do you think from, if you were graduating today and you're evaluating where do I go? Is green hydrogen a dynamic field? Are we going to need more young engineers?
Yes, we will. Yes, green hydrogen will get developed. Now I think it's going for good to get developed. It will definitely, green hydrogen will definitely be part of the energetic mix of the future. So for young students to enter a company that is developing such either projects or on OEMs or for electrolyzers, I think is a good bet, because green hydrogen will get developed all along the next decades and be more and more important in the energetic mix for the world.
Oh, that's a very positive note for our students. And maybe I'll end with one last question. Like, looking at your career, you started out as a physicist, a polymer physicist. Did you see yourself in this? How did you plan any tips for students, like young students getting on the job market? It's always very hard, and there's nothing, it's all subjective. What would be 2, 3 or any advice for a young student trying to decide where do I work, how do I choose a field? Any thoughts?
Choosing a field is very difficult, and actually, it's just you.
And you don't remain in the field where you start with,
Yeah,
right? You
exactly.
change.
Yeah,
So what remains? Like what any thoughts? Being curious, taking a risk. What worked out for you in your career when you look back in hindsight?
I would advise students to develop their network, and right from the beginning. And developing their network is just not LinkedIn. It's way more than that. It's really, as you said, being curious in their people that they meet, and to keep alive this network, because it's a source of opportunities for them, for their career, and they don't know when they will switch. So that's the first advice I could give. Second advice maybe is, I haven't done it well myself, but is probably to find a mentor at one point of their career.
Okay.
Someone 5 to 10 years older with more experience that can obviously drive them into the right direction, depending on their development, aspirations. Not everybody wants to become a manager.
But mentorship
is important for me.
Yeah. I said that was the last question, but I can think of one more question that I just can't let pass in today's environment, which is AI. Everybody is worried about AI. Is it going to take away jobs? What's happening now? What's your internal perspective? Are you using a lot of AI in development? Has it led to advantages? Is it early days? How do you view AI going ahead?
I'm using AI as everybody. AI gets developed for green hydrogen and especially for our 640 megawatt project in the eastern coast of India. We will have to optimize the operating points of all these electrolyzers. And there will be at one point AI coming into play, because the electrolyzers will degrade in a different way, and so you will have to find ways to optimize the global operating points, all individual operating points, and I'm pretty sure that machine learning will help to manage that difficult equation by learning from previous data and from,
So that's a part not often appreciated, that in these large stacks, you're doing a lot of load balancing, degradation management, or when people talk of turn down of PEM, for example, you can do a lot of turn down by just switching off stacks and things like that. Yeah. So there's a lot of optimization happening there.
A lot of optimization will be happening, and I'm sure, and our teams in John Cockerill are currently working on that. AI will help, will be part of this optimization.
But there's no reason to be scared of it. So you're still having humans, you're having a lot of engineers. That's
exactly.
No, perfect. So I think on that note, I think it was a great conversation. I enjoyed it. Hopefully,
and me too. And thank you very much, Professor.
No, thank you. Thank you for spending the time, Benoît.